Okay, so now for the second part. You are going to be using a time or a travel time graph. And it says to refer to figure 2. So figure 2 is on this page if you flip over in your document. And you're going to be looking for at how many minutes difference between the arrivals of the P and S waves for 700 miles, 450 miles, and 2,500 miles. And this is just a practice run. So these are sort of free gimme points. So make sure that you write in the answers, even from watching the video. So you can already see that the answers are 2.5, between 1.5 and 2, and 5.5. So I wouldn't skip writing in those or you're going to lose points. So we're going to start with this part here. We're going to go to figure 2 and I'm going to talk to you about how to do this. Okay, so here's figure 2. And what you should notice first is that you have two curves drawn on this figure. The first curve on the top is the S wave curve. These are the times plotted in minutes that the S wave arrives at a given monitoring station from different distances. So if you had an S wave arrive at 500 miles or 1,000 miles or 1,500 miles away from the epicenter of an earthquake, we have been able to plot, science has been able to plot the exact time that it should arrive because scientists know the speed that it goes at and they also know the material it travels through, so they're able to do these calculations accurately. The second curve on the bottom is the P wave curve, and it's a little bit light in the copies, so if you want to go over it with your pencil, that's fine. Okay, so what you should notice is that the curves are not exactly the same. The S wave curve is up here, and the P wave curve is down here. P waves, remember, are faster, so they arrive sooner. So they should have a slope that's lower than the S wave curve because the S wave takes a long time to arrive in comparison to the P wave. Remember our activity in class where we had sort of the S and P wave race, and S waves weren't allowed to run or walk as fast as the P waves, so the P waves always arrived at the monitoring stations earlier than the S waves did. And in the beginning, if the two monitoring stations were close, the P wave and S wave difference in time was much smaller. Then later at the end of the class, like when you got all the way to the back of the room, there was a greater distance in time between when the P wave person arrived and the S wave person arrived. Okay, so the first distance we needed to look at was 700 miles. So you're going to look on your x-axis for 700. And you should note that each line is 100 miles. So that's 100, 200, 300, 400, 500, 600, 700. So I'm going to make a mark on the x-axis for the 700 point. And what I want to do is I'm going to use a ruler, which will be really hard for me to demonstrate where I'm holding my camera to film this. But I'm going to use a ruler and I'm going to place it on my graph and I'm going to draw a line from the 700 mark up and make sure that I cross both the P wave line and the S wave line. So I'm going to do that. Hopefully it'll come out nice and straight. It's a little hard with using one hand on my ruler. All right, so I've drawn my line in green, and so you should be able to see that line has crossed the S wave right here and the P wave right here. So now I'm going to use my ruler again, and I'm going to extrapolate over to the Y, and I'm going to draw a line from, and make sure it's nice and straight, so I'm going to line that up there. And I'm going to draw a line from the point on the P wave over to the y-axis and the point on the S wave over to the y-axis. Okay. Now, just to help myself, I'm going to look and say, hey, the point on this P wave arrives between 2 and 3, and it's almost exactly in the middle. So I'm going to write 2.5 on the side, and my point on the S arrives at 5. So we have 5 minutes and 2.5 minutes. That's the time that the S wave arrives and the P wave arrives. And in order to determine the difference in time, I'm going to subtract them. So I'm going to subtract 5 minus 2.5, and that is equal to 2.5 minutes. 2.5 minutes is the difference between when the P wave and the S wave arrived. So I'm going to go back over here, and you'll see that I wrote 2.5 minutes as my answer for 700 miles. And I'm going to repeat that for 450 and for 2,500 miles. So 450 is going to be somewhere after the 400 mark on my x-axis. So I'm going to get nice and close and show you. Here's 100, 200, 300, 400, 500 is this number here, this line here. So I already drew for you a red line at 450. So I made my line, I used my ruler and I made my line go all the way up and made sure it went through both the P and the S waves. Here's the P wave line and here's the S wave line. I made a mark here on the P wave line for where it crossed and a mark here where it crossed on the S wave line. And then I drew a line over on both of them till they crossed the y-axis. And just so that I can use a different color to show it a little bit better, I found that it was between 1 and 2 minutes, a little bit past 1.5. And it's okay since there's not smaller lines to kind of estimate, but it's 1.6 is what I'm going to say. 1.6 minutes right here. And then I'm going to go up to where it crossed the S wave line. I'm going to look, and it's between 3 minutes and 4 minutes, and it's a little bit shy of 3.5 minutes. It kind of looks like it's a little lower. So I'm going to say it's 3.4 minute mark. So now I have to do the math again. 3.4 minus 1.6. And we're going to see that we get 1.8 minutes. Now, depending on how well you draw your lines, you might get closer to 1.5 minutes or closer to 2 minutes. And I put down both. So if you got around 1.8 minutes, that's great. Okay? All right. And then finally, the last one was for 5.5 minutes difference. Yes, for 2,500 miles. Okay, so at 2,500 miles, this is awesome because it already has a nice dark line. So I don't even have to draw my lines with a ruler. I can just go up and mark where it crosses the P line and the S line. And so I'm going to kind of extrapolate over here, and I'll see that my P is just about exactly half. So 7.5. It's halfway between 7 and 8. And then my S is just a little bit above the 13. So I'm going to say 13.2. And then I do 13.2 minus, what did I have down there? Oh, 7.5. And I'm going to get around 5.5 minutes difference. Okay? My math is a little bit off on that one. So 5.5 minutes. I think maybe this one was a little bit higher than the half mark. It's okay. I'm just trying to get this done for video so you know how to actually do it. All right? So that's how we use the time travel graph to figure out the time difference for a given mileage. Okay? The time difference for a given mileage.